Hello.
Bye.
No, I just was preparing for this episode, and I was talking to Vedran, and I think I've pushed him too far when it comes to the long wait to make my introductions and do everything else. So the thing is that today we are going to talk about the famous STEM education efforts. And specifically, I want to talk about microcontrollers because this is something that I personally quite like when it comes to tinkering. And I think that the time is ripe to try to do a quick overview of what is there when it comes to learning microcontrollers and how to program them and how to work with them. And specifically how to work with physical hardware, because this is something that I think that is missing in the normal education when it comes to computer sciences. So
Mhm.
without further ado, let's move on to the intro and then start the discussion.
Okay. Can I ask an intro question?
Yes.
Why do I care?
Uh,
Or
bec-
even better,
because even
why do I care and what's in it for me?
because even you would benefit from learning something about hardware. This
Not
is one
me,
thing.
not
Yes,
me,
yes,
me.
I know, but specifically you. And the other thing is that in today's world, when we are dealing with different services and different things that we considered, what we are considering Internet of Things,
Mhm.
the thing that is usually missing is the interface between the real world and the actual computing.
Okay.
So, in order to get any kind of information from the environment, be it temperature, moisture, position of something, is there something there or isn't it? I don't know, the height of the water, the amount of something, the flow of something, and so on. You need some kind of hardware that is going to tell you what is happening in the real world. You
Okay.
can only program so much until you hit a wall that requires you to actually understand what is happening in the environment. So, if you are, for example, trying to optimize the building that we are in,
Mhm.
you need some way to collect the data from the environment. So usually the temperature and the humidity factors of all the rooms inside the building,
Mhm.
and for this you require some sort of microcontroller.
Okay.
Or to be more precise, usually you require, from the business perspective, something that is going to be small, it's not going to cost much, and it's going to be cost effective when it comes to running and be able to be connected to your infrastructure.
Okay.
And this is where microcontrollers and different solutions that there on the market come in.
Okay.
Because sometimes, and by sometimes I mean often, the price of the microcontrollers and the development kits is so low that it is much lower than the price of the licenses for the applications that you are going to be using while constructing things.
Okay.
So I wanted to just break down what there is on the market, what can you do with this, and I want to just make a quick introduction on different families of microcontroller and what they can do, and what is the general idea of it all.
That would be helpful.
So let's start from what a microcontroller is.
Okay.
Imagine a chip that is able to execute a program, but it is lacking an operating system. So what you're doing is you're programming your microcontroller in such a way that you are directly inputting the program into the microcontroller. It is going to execute it instruction by instruction. Usually there is some assembly or some high language that is going to be translated to assembly involved. And then you end up with a purpose-built microcontroller that is going to be able to do specific thing.
Does basically does that work like I don't know, uploading a firmware?
Usually it
It's like
is.
that. Okay. I never did this, so I really don't know all of the information. So very
Basically,
helpful.
there are two ways to do it. The one is to use some framework or some solution like Arduino or ESP32, or there is a plethora of them, more than 15 to 20 different families of microcontrollers that you can get,
Okay.
that usually provide you with some sort of a simple solution to upload and execute your programs. Or the other solution is to get an actual microcontroller, program it directly,
Mm-hmm.
so directly create a binary, upload it using a microcontroller programmer, and then create your own solution on your own board that is going to be specific for your application.
Okay.
The main difference is that when you are buying something like an Arduino or something like ESP32, these are the two most popular things, or Raspberry Pi Pico that has been on the market for the last couple of years. What you're getting is the board itself is going to be populated by the microcontroller, but also by all the different things that you need. So ADDA converters, the sometimes LEDs, a lot of pins that are able to connect to the outside world. It is going to get everything that you need to create your solution. It is going to be, let's say, multi-purpose. So it is going to have much more than you are going to be needing for a particular thing, but you can use it to develop different solutions for different things. So basically, what Arduino is used for is to create the initial solution stack
Okay.
that you are going to then either use as it is, because
Mm-hmm.
the board itself is cheap, or you're going to translate it into a board that is going to be specific for the purpose, so that if you need to create something that is going to be produced in thousands or tens of thousands of different units, then you can dive the cost down. Because usually it doesn't make sense to buy a whole Arduino board and then create a single purpose computer. You're probably going to be using your Arduino board to develop something, and then you're going to scale it down to just the microcontroller and the minimum required number of electronic parts that are required for the solution.
Okay. So this is supposed to be price efficient.
This is first and foremost supposed to be user friendly. The Arduino is supposed to be an
Okay.
introductor to you understanding how to use the electronics,
Mm-hmm.
to understand what different protocols are, what different sensors are, how do they work, how do they communicate to the microcontroller, and so on. Because in the world before Arduino and the world before ESP32 and cheap microcontrollers, what you actually had to do, you had to get the microcontroller programmer.
Okay.
You had to get the microcontroller. You had to program it using binary that you would uh, basically have to create on your computer. Then you had to compile it. Then you upload it to microcontroller.
Mm-hmm.
Then you had to create the entirety of the infrastructure around the microcontroller to be able to test it. Right
Okay.
now, you can buy an Arduino and be by using the Arduino's IDE that is free, you can get for, I don't know, $10 or $15, you can get from zero to programming a single microcontroller in probably under 15 minutes.
Okay. Cool.
And the only thing that you need is the Arduino itself, the USB
Mm-hmm.
cable, and the free software that Arduino provides you.
Okay.
And this is the beauty of the Arduino. This is the same with all the other solutions. So the STM32, the Raspberry Pico, the Teensy, the
Raspberry Pico being the solution that's basically Raspberry, but for this intended purpose.
yes, the main difference is that the processor on the Raspberry is completely different. So the
Okay.
Raspberry is the name, but Raspberry Pi and Raspberry Pico or Pico are different. One is the microcontroller, one is the processor. So
Okay.
one is a system on a chip, the other one is actually a microcontroller. But main difference is the price. A Raspberry Pico is $4.
Okay. Get
So
it.
you get the entirety of dual core ARM Cortex,
Mm-hmm.
and 264 kilobytes of RAM and 2 megabytes of flash memory for
I already
$4.
like that.
So for $4.
Okay.
So this is something that you can actually use to program this microcontroller or this board has 26 pins to connect to SPI, I2C, UART, and so on and so on. You can use C or C++ or MicroPython to program it. You have
Okay.
a loader. And all of this for the price that can be lower than the USB cable that you're going to be using to program it with.
Okay.
And this is the idea. The idea is to have ultra cheap hardware that is simple to use and simple to learn.
Can I ask you
Yes.
a little bit more, let's say, of a personal question? How did you get into this?
Um, I
Was there a
always
specific purpose, or was it just your tinkering habits that got you there?
it's the tinkering habits and my main. I have a few friends who are much heavier into electronics, and I was always watching them doing things in microcontrollers.
Okay.
The problem is that I never had the time or the patience to create my own printed circuit boards.
Okay.
So I didn't want to go into this part of development because it required too many things that I didn't want to do. It is not that I dislike them doing them, but they require specific knowledge and they require specific. They require amount of time that I wasn't willing to spend on this particular part of the ecosystem because I'm not the guy who is heavily into electronics. I'm not the guy who wants to
Okay.
solder hundreds of electronic components on on a board just to get a single solution done.
Okay.
But at the same time, I was interested in how microcontrollers work.
Mm-hmm.
So the solution that enables me to just have my sensors, have my microcontroller, have a USB cable, and be done with the hardware part,
Mm-hmm.
so I can then focus on the software part and on tinkering, is something that is extremely entertaining to me, and I want to do it. And this is the reason why I tried different things. For example, I don't know, BBC Micro, Atmels, Picos, and so on the world, because um, this specific market basically was created when people started developing Arduinos.
Mm-hmm.
First, Arduinos were simple. You had Uno, you had Duo or Due, you had Zero, and then you had different solutions. But what they did is that they basically created a board that would support something that you wanted to do. So the first one was Uno, and the Uno was the cheapest one and the simplest one to use. It had a microcontroller on it. It had some sort of some amount of RAM, depending on the model. Right now we are up to model or release 4, so there are different Uno boards, and it was cheap. It was probably
Okay.
the first microcontroller that you can buy for under $20 with everything built in. So $20, you buy it, plug it into your computer, and you're ready to I don't know, read temperature.
How many of those did you buy?
I have no idea. Probably tens. Number is in the high tens. So I would say under 20, but more than 15.
But what are you using them for?
Different things. I'm using one of them to drive a display. I'm using one of them, or no, a couple of them, to get the temperature inside my house that I'm not living in, to actually check on the temperature of the pipes that are going into the house, so I can actually get the information when they're freezing.
Mm-hmm.
In the last couple of years, I have been exchanging them for specific units, like, I don't know, Shelly or some Tuya-based Chinese solutions. Not because my solution is bad, but because the newer solutions are better.
Mm-hmm.
The thing that is a big problem when you're programming something like Uno is that Uno is big.
Mm-hmm.
And you need to not only do the controlling, but also you need to have some sort of a power source. And
Mm-hmm.
you need to make sure that your power source is going to be something that you are going to be able to take care of. By that, I mean that if you are running your microcontroller, your battery, whatever the battery is going to be bigger than what should be needed if you are able to do a dedicated microcontroller.
Okay.
The dedicated solution usually, since it's dedicated and since it usually is done by in huge numbers, it can go into deep sleep mode, so you can get a battery lifetime of months,
Months.
even years. And when you are dealing with Uno, since you are not able to do a lot of things that you could be doing in a specific microcontroller, you're probably going to be dealing with the battery that needs to be refilled every couple of weeks or every couple of days, depending on what you're doing. So usually the reason why I was dealing with this is just tinkering. But as I said, I got a lot of them in different times, and I was doing a lot of things. And also, there is one more thing. When Uno came out, Uno was a specific thing that didn't have any other ways of connecting other than USB.
Okay.
What happened is that then they upgraded to Wi-Fi. They upgraded to include boards that are able to connect to the Bluetooth. So every time a new revision came out, I usually bought a few of them.
Okay.
This is one thing. The other thing is that you can buy cheap, not so good clones from Chinese manufacturers, but they are extremely cheap. By extremely cheap, I mean $2 or so. So if you are capable of dealing with something that is not going to be as reliable as an original Arduino or original microcontroller that they are dealing with, uh, you can do things that are extremely cheap. By extremely cheap, I mean, for example, if you're controlling, I don't know, a light from the Uno. This is one of the things that I'm using it for, because it is able to directly control the LED strips that I use for the lighting. The light itself, so the LED strip, is going to be 10 times more expensive than the Uno controller. So now we have come to a point where your switch is more expensive than the controller. So the
Okay.
light switch is expensive, more expensive than the controller.
Okay. I know that it sounds completely crazy when you put it like this. It's not only that. When you are dealing with, let's say, a little bit more up-to-date concepts like smart house and whatnot, when you start dealing with those switches, then the price difference is going to be insane. Even switches can cost 50, 100 euros easily, or dollars, or more, depending on which ones you use as well. But so you described a couple of patterns, of, let's say, a couple of different things that you use them for. Which programming languages did you use to program them, or did you just use existing prototypes of programs or
I usually
existing
use
code?
if I'm dealing with Arduino, I'm usually using their language that they are using for the IDE. So they have their own. It's something that resembles C, but it's much more easier to understand than C because it is higher level. So what they did is they created prototypes of the functions so that you can use the functions that they already created in order to program in the high level level. So for example, you don't talk to the pins by themselves. You just say, okay, pin on, pin off, read the pin, write the pin, and that's it. And
Basically, like
the magic,
procedural programming.
yes, the
Okay.
magic happens somewhere underneath. So you don't need to take care of the buffers. Don't need to clear the buffers. You don't need to explain to the pin what needs to be done. You just define it, and then after that you can just use it. So
Okay.
it is easy to use. And what is the main difference between different Arduino models is usually the what the module is capable of. So Uno is
Okay.
simple, but simple enough to be used for different things. It's 48 megahertz. I'm just reading out the current version. So R4 minima. So this is the simplest one. It uses 5 volts for the
Power?
power supply. It
USB
is
probably.
48 megahertz, 32 kilobytes of SRAM, 256 kilobytes of flash memory, and 8 kilobytes of EPROM.
And costs?
Let me just check. $22.
Okay.
So, but the idea of this one is it is supposed to be user proof. So if you are if you misconnect a sensor, if you make any kind of error with, for example, trying to overload the pins by, I don't know, using a sensor that's going to try to get too much power from the pins, you can actually you can expect that this is going to probably survive it. So it is
Okay.
designed to be for beginners, and it has enormous amount of space on the board itself. So you can take a look at the board and you can see that actually there is spacing. The spacing is completely on purpose. So they decided to make a huge amount of space available on the board because they want you to be able to plug it in even if you're not seasoned in electronics.
Okay.
And this is one of the things that makes sense because this board is not that big. This board is basically hand sized. But if you take a look at different products that they have, that they are using for things that require the product to be smaller, then you suddenly can go into Arduino Pro series that can be then real-time monitoring. They can be configured as a real-time monitoring system. They are supposed to be connected. Some of them are supposed to be connected on the DIN connectors inside your switchboard, so inside your power distribution board. They have different boards that are for different things that can make sense if you're requiring something extremely small. So there is a nano. There is there was even I need to check if this all that this is alive. There was even a waterproof model intended to be sewn.
IP65 or whatever that was.
I think it was even better than this. So the idea was that it was able to be sewn into garments
Okay.
because it had pins that were intended to be sewn into with a special kind of wire that was much more it had the high tensile strength, so you could actually create a wearable model of something and connect things with wire that is going to be much akin to a normal I'm lacking words, so the
Sensor. What?
no the coordinates.
I cannot remember.
We are missing.
Koniec, yeah.
We are missing the actual English word because this is not something that we do. Thread.
Yes.
So basically, the wire that can be used both as a thread, so as something that can be sewn into the fabric, but also can be used to conduct power. So
Okay.
people have created in the entire, I don't know, gowns, wearable, basically every kind of wearable thing that contain. Usually, they contain either LEDs or some sort of sensor to do something. Usually it was LEDs because it makes this makes the most sense. You create interactive garment that you can then wear and have there were many skirts created with LEDs that were
Disco ball effect.
yes, they had a disco ball effect. The idea was to highlight the legs of the person wearing it. So
So Peter Gabriel's sledgehammer variant.
yes,
If you know the life.
yes, but in real
Yeah,
life.
Okay. Excellent. Cool.
So people have been doing this, and this is the beauty of the microcontrollers because you can buy different things. You can buy different things based on what you're trying to do, and the cost of it is not that great.
Question.
Yes,
What type of signals can you connect to that?
depending on what you want to do. Usually, it is able to connect using multiple protocols. Usually, it has input ports that are either analog or digital.
That's
So
excellent. That's exactly what I wanted
it
to know.
has some sort of analog to digital converter, so you can read the sensors that are going to give
Continuous.
you continuous
Okay.
data. you can usually talk to.
Obviously, if it's digital, then discrete data is going to be as well.
Yes,
Okay.
you can have the digital input ports. Also, you usually have output ports, so you can
Okay.
actually output both the digital and analog signals. And
Like in a programmable fashion.
yes,
Okay. Cool.
and usually, so you can actually
Basically, multiplexer.
yes, but also you can I don't know, directly talk to, for example, speakers.
Okay.
This is one thing, and the other thing is that usually you have to I2C or UART or SPI protocols that enable you to connect to different sensors that are digital, but you can then multiplex the sensors. So it is simple to use a single controller to, I don't know, have 20 different temperature probes at the same time using I2C. If you are able to do this. For example, this is the controller that I was talking about. So this is a small controller that can be used as something that you can sew into your garment, or there are even smaller ones that can be used. For example, this one is basically as big as the width of the LED tape that you're going to be using, the LED strip that you're going to be using. So these are different things that you can do, and depending on how the ideas that you have, you can scale and you can create whatever you want. One of the most interesting ones for me is the tiny microcontroller. I need to find the image for you, and then I'm going to. So the idea was to create as small as possible. Microcontroller is going to be as small as possible. And what they created was the microcontroller that is a little bit larger than the USB port that it connects to.
Okay.
And then you can tear down, I'll find the image. Then you can tear down once you have done the programming. So you don't need any boards, you don't need the cables. It plugs directly into the USB port. And then once you've done the programming, you can pull off the USB connector as a tab. And then you are left with a small microcontroller with something
That sounds like something perfect for listening devices or something like that.
the idea is something like this. So this one has the headers.
Actually, I saw something like this. Yeah. Okay.
Yes, it's called DigiSpark. I couldn't remember the name. But the thing is that you can cut it along the USB connector. It is designed in such a way so that you're only left with this part of the board, and it doesn't have enough much memory. It doesn't have. It's not too complicated, but for example, it can directly control lights. So for simple lights, something like in a I don't know, in a toy, or in something that you want your lights controlled in, I don't know, a car. If you are into modifying old Golfs and creating LED lights for no particular reasons.
Welcome to Balkans.
Yes, but this is the thing that you could use. And this one is, I think you have to buy 5 of them to be able to buy them. The
Because
price
they're
is-
like $2.
Yes, it's something insanely low, like I don't know, $3 for 5 or something like this. So I'm now coming to my main point. The thing is that
Okay.
I want to say that if you are interested in tinkering, the actual amount of money that you need to give you need to spend in order to go into tinkering mode and try to experiment with microcontrollers is minuscule.
Okay.
You can buy your basic set of what you need for the for programming microcontrollers for something like, I would say, $30. And by $30 I mean for $30 I would probably buy an Arduino, either one, or ESP32. This is another set of solutions that you can use. And then I would probably buy a set of sensors from any Chinese site.
Okay.
The reason why I would buy sensors from a Chinese site is because the sensors that they are selling are completely passive. So, for example, they have, I don't know, a read contact, I don't know, infrared sensor, and so on. So basically, what they're doing is they're creating a small board that you can connect to, and then they just solder in a single sensor without any additional electronics. So there is nothing to screw up there. So you can actually buy a bunch of sensors that you can experiment with, and you can learn a lot.
Every single time that you mention the acronym ESP, my mind goes to old sound cards.
Yes, I know.
You cannot help it. Okay, what about, let's say, output connectivity? Not in terms of sensors or binary or digital or analog, not in that sense. Let's say that you want to connect a, I don't know, LCD to it.
It's much more complicated, but I don't think this is the main use case.
I know it's not, but still.
The thing is that you then need to create some sort of either a VGA controller or a HDMI controller. You need additional protocols, and you need a way to control them, and this is usually out of the scope of what the microcontroller can actually do.
Okay.
Because basically what it requires is a lot of memory to store the program data that is going to just be the data that is going to be able to create the signal that you are looking for in the VGA.
So that's kind of like one of the major differences between that and Raspberry Pi.
Yes, but what you can do with things like this is usually you are not using the.
I know, you just do it, program it, pump
Yes,
the firmware in and leave it there and forget
yes,
about
but
it.
what you usually do is you are probably usually using I don't know segment displays. You are usually using LED matrices that are small. I don't know, two rows times 12 letters or so that you can actually give the user the whatever they need. E-ink displays are usually used, and there are small color displays that you can directly connect using I2C.
You know what your previous example of using a couple of rows of LED lights reminded me of?
No?
Our favorite computer architecture course.
Yes, I know. But what I wanted to say is that my main reason why I like this is that you can softly introduce people who don't understand what DSP actually is. What is the difference between an analog and a digital sensor? What is the difference?
Without them understanding that on a theoretical level.
Yes,
Okay.
but you can introduce them and tell them, okay, now you have, I don't know, 1 to 5 volts, and this is going to become 0 to 1024. And not try to explain them how a conversion works. But just say, okay, magically, 0 is going to be 0, 1024 is going to be 5 volts, and there is going to be some steps between. And then you can actually measure something using this sensor, and then it can become a digital thing that you can then use.
And then you would probably want to explain to them how linear and logarithmic scales work and stuff like that. But
the thing is that since Arduino is so popular, there are a ton of sensors that are doing the calculations by themselves. So they're already calibrated.
Yeah.
So for example, if you're buying, I don't know, ultrasonic sensor, it's going to give you the distance in such a format that you can just actually say, okay, I know what my stops are, so I'm measuring from 0 to, I don't know, something, half a meter to 2 meters, whatever. And then I'm going to just get the results that are going to be calibrated. So you can actually get the result in meters, not in steps, whatever the steps are. Also, you can take a look at what the prices are. We're going to put it in the video. So the price for the sensor module set is something like $8.
And there are millions of them.
Yes, and the thing is that these are not going to be sensors that are immensely powerful or immensely precise, but you are going to start to get the feeling on how it is to program the sensor. And then once you realize what we are requiring the sensor for, so for example, this is the capacitive soil moisture sensor for $1. This one is probably, I will say, 60% precise on what it could actually be. But once you start dealing with this one, then you say, okay, now I can measure moisture of the ground. Then I can, I don't know, measure the amount of weight that is being exerted to the ground, so I can do something. And then after you create in your mind, you create a mental image of what can be done, then you're probably going to get an aim for the more precise sensors, for more precise electronics. But this is the way where you are not afraid to fry something.
Okay. Moving on from the idea of sensors for temperature or moisture or fog or gas or whatever, how about, let's say, using this platform to control something a little bit more complex, some kind of a servo motor or something like that?
There are modules that are able to directly control the servo motors. So you just tell them motor whatever, RPM whatever, or you just control the stepper motor, so you can say so many steps on the left, so many steps on the right, and so on. So there are different modules that enable you to do things.
So you could basically do some robotics related stuff with that as well.
Yes.
Okay.
Yes, there are also things that are called shields. Let me talk about shields a little bit.
Okay.
So basically, regardless of what the underlying microcontroller or generation of microcontroller we are dealing with, so either
Okay.
be Arduino, ESP, or whatever, even Raspberry Pis have those.
ESP.
They have the pins are usually placed in such a way that they are standard across all the models that Arduino is dealing with.
Okay.
And then you can buy additional modules that can be stacked and plugged in directly to the board itself, and they are called shields. So, for example, I don't know, this is a shield that is intended to be able to enable you to connect a lot of sensors. So
Okay.
you have some.
Basically like CM4 but
Yes, but what this actually is, this is just a patch
panel. Yeah.
patch panel.
Yeah. Okay. I
It's
get
a
it.
patch panel that enables you to connect some sort of, in this particular case, this is some sort of power here, and then you have a reset, and then you have a bunch of, and by a bunch mean, I don't know.
18 or something.
I'm not going to count how many of these. This is 18 positions, but these 18 positions each contain 3 leads. So it is no 4 leads. Sorry.
Yeah.
So it is probably you can connect
72.
up to. It's probably you can connect up to whatever is the maximum amount of sensors that this board can tolerate.
Okay.
I really have no idea what the limits are in this particular case, because it would require me to just go much deeper into the board that we are dealing with. And the thing is that you can even buy training kits like this that enable you to plug in directly the Arduino board, and then you have everything else that can be done, LEDs, buttons, displays, and so on a board. So this is ideal to teach somebody how to do something.
Okay. Which types of memories does that use? Is it just SRAM or are there?
It depends on the processor.
So-
Usually it's SRAM because it's easier to, but it usually has a combination of small part of static RAM. Then it has some dynamic RAM that can be used for additional storage. And then there is some sort of non-volatile RAM that is going to hold the program that you put in. It usually is some sort of EEPROM.
EPROM, okay.
But it depends on the control itself.
What about storage? SD cards or something like that? Or
You can buy either shields that are able to support the storage or the SD card or both. You can even buy shields that are able to support the SATA controllers, the NVMe controllers, and so on, depending on the microcontroller that you're dealing with. If the microcontroller is much more advanced, I don't know, multi-core ARM microcontroller, it usually has the capability of driving those things.
Usually has a PCI Express controller, then you
Yes,
can
but
I get it.
but the thing is that
I know, not intended use case.
this is not
I know.
intended use.
Okay, just asking how far you can go with this.
You can go basically what you can do is the microcontrollers right now are able to go from single sensor, 2 leads, $1 to whatever is the lower end what Raspberry Pi is capable of doing. So they're capable of doing, I would say that the main delimiter would be the graphic capability. So it isn't feasible to create a complex graphical interface with a huge screen on a microcontroller. It has been done, but it's not feasible. It's not something that you should be doing. And this is probably the reason why you should buy a Raspberry Pi.
Okay, I definitely agree with that.
And specifically, the price is like this. So if you are dealing with something, usually the microcontrollers stop, the educational ones stop somewhere on the $35 to $40 mark, because the Raspberry Pis start there.
Okay, definitely makes sense. Okay, what else did I want to buy? Ask. Let's say to kind of go in a little bit of a more advanced direction. Let's say that you want to connect multiple, let's say, Arduinos and create some kind of a distributed project. How do you
Mm,
do that?
there are multiple things that people usually do, because people usually do, since the microcontrollers themselves by definition are not they don't have a high clock cycle, so they are
Mm-hmm.
relatively slow. We are
Mm-hmm.
dealing with megahertz, we're not dealing with gigahertz units usually. What people do is they create distributed systems. So, for example, they have a separate microcontroller that is going to deal with the sensors, separate microcontrollers that is going to be dealing with whatever the display is to be able to
LED
be
lights, let's
controlled.
say.
No, the controller sensor.
Okay.
Then you have something that is going to be dealing with lights, and then you have a central microcontroller that is going to be coordinating the entire system.
How are they wired? Like electrically connected directly one to another, or?
Depending on what you're trying to do, you can use I2C or WART or whatever. You can even connect them through the Wi-Fi,
Mm-hmm.
because they are available. There are web servers available that can do APIs, so you can actually create your own distributed network. And we basically have one here in the building, but nobody notices it. These temperature sensors
Yeah, yeah.
are. I was buying those because I actually was interested. Why did they use this? This is the cheapest one that actually makes sense, and they are something like $5 or $6 a piece. They use one AA battery. It lasts something like 6 months or so, and they are Wi-Fi connected to the central server. And you can use the API to talk to them, and they're going to respond with temperature and the moisture.
The reason why I'm asking is because I'm considering for future purposes, a couple of years down the line, we're going to start doing something related to distributed computing. And I'm trying to figure out what kind of a hardware platform we're going to use for our students.
I think that you can, by using the simplest of the simple controllers here, you can create an environment where people are going to be able to program and try things out.
Mm-hmm.
And my main reason why I like these solutions is that this is cheap.
Mm-hmm.
If somebody makes a mistake in a let's say you are doing HPC solution, you have a rack, you have
Okay, I didn't want to compare that
yeah,
directly, but okay, okay, I get it.
let's say that we are trying to teach people how to do HPC solution, and we are trying to teach them how to interconnect different parts of the HPC solution. You're usually dealing with boards that are going to be $200 plus per board,
Mm-hmm.
and you're going to be creating a cluster of, I don't know, 16 of them. It's much easier to break them, or it is from students' perspective, they don't know what they're doing. So if they break a board that is going to cost $200, it's not the same if they break a microcontroller that's going to be $2.
Yeah, agreed.
So, but the core principles are still standing. Interconnection, semaphoring, interprocessor communication, and so on and so on. They still stand, even if it's a microcontroller.
Imagine trying to teach them, for example, in a distributed way. Let's say that you have multiple microcontrollers connected in some
Yes.
fashion, doesn't really matter which one, and then to create some kind of a highly available solution for temperature reading and humidity and whatnot. If one of the microcontrollers fails, the other one takes over, stuff like that.
The thing is that people have already created those, and by high availability solution, it usually means that you are just spreading hundreds or thousands of sensors around, and then you just say, okay, if anyone fails, I don't care. I have even seen solutions that were intended to be thrown out of the plane.
Mm-hmm.
So there were little spiky controllers that, if thrown out of the plane, would just push into the ground, and they had a life of, I don't know, expected lifetime of something like 3 or 4 months, and then they would actually decompose.
Mm-hmm.
So you would just end up with a piece of ceramics on the in the field.
Okay.
Okay, I'm not saying that this is completely sane from the
If it's
ecology
for
perspective.
no, maybe it's something related to eco projects or something like that.
But the thing is that when we are dealing with things, what we want to do is we want to be able to collect data.
Yeah, that's exactly where I'm going with this.
We are right now in the middle of a revolution that is going to be called AI revolution probably in the future. But what AI revolution is just a fancy name of being able to compute and being able to extrapolate second generation data from whatever is
On the input and then
yes.
what
So
has
what,
been.
what
Yeah,
what is
okay.
happening is that we are just right now dealing with enormously capable systems that are capable of uh, the doing the computing on huge amounts of data, petabytes of data,
Mhm,
and we require the data sources.
mhm,
Right now, what the data sources are, the biggest data sources that we are using are usually logs,
mhm.
sensors inside the servers, and so on and so on. But we are lacking when it comes to sources that are collecting data from the environment.
Mhm.
For example, right now, smart meters are a thing. The capability of you being capable, the capability of reading the, I don't know, power meters or gas meters or water meters from afar.
Mhm.
And when everybody talks about gas meters or power or the smart meters in general, what they're usually thinking about is, okay, I'm going to be able to read the amount of power that the person spent because I want to calculate how much to charge for the power that they got. The idea of the smart meter, once it is connected, also enables you to do different things that are completely out of the scope right now. For
Okay.
example, if you are monitoring or if you're capable of monitoring water consumption,
Mhm.
if you know where each meter is, you can actually use AI or
Mhm.
machine learning or whatever you call it
Mhm.
to understand where the water is being lost.
Mhm.
You can
I get
actually
it. Yeah.
you can actually see where the pipes have broken. You can see the power outages directly as they happen. You can get to the root cause of the power outage because you understand how the power outage spread throughout the system. So suddenly, a smart meter is not only a way to charge people,
Mhm.
but also a good way to understand how the system behaves and how to tune it so that we can become eco-friendly simply because we can, I don't know, power down some part of the system, eliminate losses in some part of the system, and so on.
No, that's a little bit more towards, let's say, Internet of Things, in a sense.
Yes, but the
No,
controllers are the
perfectly
are the
reasonable.
gateway drug to the
Yeah,
Internet of
okay.
Things.
Okay, now the last question that I have, because before we wrap up the episode, is related to security.
That is done. That is done because the security is something that you have to put in for one simple reason. The microcontroller doesn't have an operating system.
Mm-hmm.
So whatever you're building, you need to build your own.
Mm-hmm.
If you want to read a sensor that doesn't have a readily available function or readily available API call, you have to build it for yourself. So the security part is also something that you need to build. If you are creating API capability in your IoT sensor or microcontrollers or so on, you
Like
need
API call, get me temperature, stuff like
yes,
that. Okay.
you need to make sure that you are doing it right. But on the other hand, when it comes to microcontrollers like this, there is not a lot of things that you can do when it comes to security problems, because from the start it is already complicated to update the firmware on the microcontroller.
Mm-hmm.
Finding a way to do it remotely is usually much more complicated. So tweaking with what microcontroller has in its own memory and tweaking the EEPROM
Mm-hmm.
remotely is usually much more complicated.
Okay.
I'm not saying that this is impossible.
It's not.
Somebody is going to find a way. But if I want to do something bad, I would probably aim for Raspberry Pis.
Yeah. Okay.
Because suddenly I
Yeah.
have an operating system, the
Network ports and whatnot. Yeah.
attack surface is much, 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 much larger. So I'm going to find a way to get in. And I also get the support from the operating system that helps me to maintain to have my persistent attack.
Presence on the system.
Yes.
Yeah. Okay. And the last question: How would you, from the perspective of what we have here on the our in our jobs and especially in the Combarch course, how would you let's say correlate the topic that we are discussing and education,
My
specifically computer science
Yes and no.
education?
The thing is that, from my perspective, every school, and by school I mean not university, but I mean even elementary school,
Okay,
should be given each one of their students cheapest kit like this for free,
okay,
so that they can actually start thinking how to program them. I know that probably 90% of them are going to go into waste because nobody's going to try to use them. But even if we get 10% of the people to understand how microcontrollers work in the elementary school, because it's not that complicated, then we are going to do immense things when it comes to universities.
yeah.
If at university, I
Okay.
would make it compulsory.
Okay, to just interject with one thing, the fact that they are so low on power, in terms of CPU power and
Yes.
memory, basically means that people will also have to, with time, not from the get-go, because it's impossible, they'll have to kind of learn how to do programming in a much more optimized fashion than what they would do if they had much more resources. And if you start with that concept early enough, later on in life, if somebody wants to become a programmer, that might actually leave some long-lasting positive consequences on the way in which people think about programming as well.
Yes, but the other thing that I'm much more interested in is to for the people who are going into computer sciences to understand the interface between the physical world and the software world.
Okay.
This is a huge lack of. There is a huge lack of knowledge when it comes to programmers nowadays, because sometimes, more often than not, they don't understand that they are dealing with actual physical people, physical users in the physical world, and they need to be able both to interact and to collect data from the world.
I'm guessing that using analog sensors is a special chapter of that.
Yes, because people need to understand that not everything is digital and not everything is simple to understand and simple to use, because it needs to be done in such a way that you can actually
Extrapolate real data from
use
it.
it.
Yeah, use it.
Use it. And this is one of the biggest holes in the education when it comes to programmer, because usually when people are dealing with programmers and people who are studying computer sciences, they start on the assembly.
Mm-hmm.
And your CPU is a given.
Mm-hmm.
You say, okay, I have a CPU that's going to run, and then I'm going to do the assembly, and then I'm going to control the storage, the memory, the processes, this or whatever. But nobody says, okay, now I need to understand the environment that I'm running in.
Mm-hmm.
And usually they don't learn how to do this. They don't understand what can be done using different controllers. Just to close the thing up, okay, this is the BBC microbit. This is the
Yeah,
thing that
a lot of people are using that.
yes, because it has it is small, 4 by 5 centimeters. It has a bunch of diodes. It has it can be used for the different things. But uh, my main thing that I want to mention is not this. The main thing that I want to mention is that even when it comes to enterprise,
Okay.
you can do immense things once you realize that you have sensors.
Mm-hmm.
I don't know which one. Okay, everybody now has it, but I know which vendor started it. Do you know the modeling toolkit that enables you to, if you have a stack of servers inside the rack,
Mm-hmm.
that is able to use the sensors inside the servers, because there is hundreds of servers,
Mm-hmm.
that the framework that enables you to see the entirety of the rack and the thermal signatures of everything inside the rack, so that you can actually understand which part of the server, of which server in which rack is generating too much energy or is not generating enough. Did you
Mm-hmm.
see? Have you seen this solution?
Yes, I have.
And I don't know who started with this.
I have no idea, but I've seen that in production in a couple of environments
Yes,
locally.
and this is basically something that doesn't cost anything. Somebody just realized, okay, we have a motherboard. The motherboard has, I don't know, 20 temperature sensors because they're cheap.
Mm-hmm.
Now, if I stack them up and understand when in the 3D space they exist, I can realize where the hotspots are in the server.
You can actually model that as well.
Yes, but the thing is that this is a simple solution to a simple idea that was possible 20 years ago. But nobody came up with it because nobody was thinking about it.
You just gave me the craziest and the coolest idea that I can employ for my PhD. We'll discuss it later. Okay,
Okay.
close it up, man.
Okay, this has been my big rant about why I like microcontrollers, why microcontrollers are good for you. I'm going to be putting, or Vedran is going to be putting links that I'm going to give him for different generations of microcontrollers, different solutions. I'm going to include some controversial Chinese sites because for some reason or the other, people think that once you link to Chinese manufacturers, that you are doing some disservice. I think that they are a good source of electronics that you can experiment with.
Okay.
And when it comes to microcontrollers, this specifically is a good thing because you don't want to break expensive hardware. And you want to see what can happen if your hardware is not calibrated enough. I'm not going to say it's bad. I'm just going to say that the percentage or the variation between different sensors is going to be much greater when they come from a reputable source or when they come to an anonymous market in China. It's not dumping on China. There is also basically everything is created made there. But if there is no quality assurance, you're going to get sensors that are not going to work. But this is part of the process because you are so low down in the hardware. You want to learn also that sometimes hardware is bad once it comes from the factory.
Okay.
So this has been me trying to get you interested in microcontrollers. I hope I did. If you have any questions, just pop them in the comments.
Or on our Discord server.
Yes.
Okay. See you in
Bye.
the next episode.